Good morning, everyone. This is the post-launch news conference for our SMAP mission, and here to discuss the activities from this morning. First of all, our Kent Kellogg, the SMAP project manager from the Jet Propulsion Laboratory in Pasadena, California. Scott Higginbotham, the NASA Alana 10 mission manager from the Kennedy Space Center. And Jeff Yoder, the Deputy Associate Administrator for the NASA Headquarters Science Mission Directorate. And we'll begin first with a very happy Kent Kellogg.
Yes, thank you, George. We had a terrific ride into space this morning aboard the United Launch Alliance's Delta II vehicle. They deposited us exactly where we wanted to be with very good accuracy and precision. We had a very nominal separation, and I believe we have that video we can play of the separation sequence. As soon as we separated, the spacecraft onboard sequences very rapidly established communication via the NASA Tracking Data Relay satellite system. They started the solar array deployment exactly according to the nominal plan. And you can see here the solar array beginning to deploy with the Earth as a fantastic backdrop. Very apropos for a mission about the Earth that's going to provide very important data on soil moisture and its freeze-thaw state. The solar array deployment took about as long as we expected. The video quality here is actually quite exceptional. And there you can see the first panel starting to deploy. By all indications, this is one of the cleanest, most visible deployments we were able to see. The camera, by the way, is on the upper stage of the vehicle. The United Launch Alliance folks had arranged to let the upper stage wait for about 150 seconds while pointing at us so we'd have an opportunity to capture the array deployment. And we were not sure we'd be able to see the entire deployment in the video, but we were able to, and it's fantastic. The spacecraft attitude control system got us pointed at the sun, so we were in a power positive situation within a few minutes. We had our first contact with the Near Earth Network station at Svalbard within 20 minutes of separation. That was right on the nominal plan. We were able to get commands into the observatory and verify that they'd been executed. We followed that with a second pass over the Alaska satellite facility near Fairbanks, Alaska. Again, that was a very nominal pass, and we were able to get good telemetry. And we just followed that up with a third pass over the McMurdo ground tracking facility. So we've been able to now verify that we have good communication through the space satellite tracking and relay system and through all three of the major NASA near-Earth ground stations that we plan to use with the mission. The observatory health is excellent. We have all of our subsystems are being powered on and checked out and look to be working as we have planned. We have not turned on the instruments yet. We will not do that until about 11 days after launch. But all the engineering subsystems, the communication, the guidance and control, the computers, the power subsystem are all operating nominally, and we've got good temperature performance. So this is a fantastic start to the soil moisture active passive mission, and I want to express thanks to the NASA Launch Services program people that worked so hard to get us into space, and the United Launch Alliance folks with their fantastic Delta II vehicle that gave us a wonderful ride into space this morning. So we have a lot of happy people on the project side, and we're looking forward to getting this mission off and getting some very valuable data returned for the scientists very quickly.
Thank you, Kent. And now to Scott Higginbotham, the Alana 10 mission manager from the Kennedy Space Center. Scott?
Thank you, George, and good morning, everyone. Let me start by saying we too want to thank United Launch Alliance and my colleagues in the Launch Services Program for the amazing ride to space today. All 4 of the Alana 10 CubeSats were ejected from the second stage per the mission timeline and are flying free. The way we force these CubeSats to operate, they cannot turn on their transmitters for a period of time after they're deployed in the interest of protecting the second stage and the primary mission. So the current timeline has the 2 Firebird spacecraft and Griffix turning on their transmitters about as we're speaking right now. What they start doing is beaconing to the ground, sending a brief radio signal saying, I'm here, and they wait for someone to contact them. We don't expect to hear back from the spacecraft for a little while, waiting for them to come over their ground stations here in the continental United States. But we may actually hear of their beacons early coming from European ham radio operators who sometimes listen in for the signals and then communicate via the internet that they've heard from our spacecraft. ExoCube will turn on a little later, about 11:30 this morning, and it will start beaconing to the ground as well. In summary, great ride today into space. We're looking forward to getting the return from these satellites as they begin their missions, and I do want to acknowledge all of the university students out there that had a part in building these spacecraft and getting them into space today. George?
Thank you, Scott. And now Jeff Yoder, the Deputy Associate Administrator for the NASA Headquarters Science Mission Directorate. Jeff?
Thank you, George. What a morning. I want to, as my other colleagues, want to congratulate the entire SMAP team, the NASA Launch Services Program, our contractors, our partners in academia for a wonderful launch this morning. I know a lot of people are eager for the SMAP mission to begin delivering the most accurate and highest resolution maps of soil moisture, ever obtained. This data will benefit not only scientists seeking better understanding of our planet's climate and environment, but it's also a boon for weather forecasters, agriculture and water resource managers, emergency planners, and policymakers. SMAP is another example of how NASA is making a difference in people's lives around the world, and that's just tremendous. Data and applications for societal benefits are directly accessible to decision makers, stakeholders around the world. SMAP joins several other NASA missions already in orbit in different stages of the water cycle. They give us unprecedented measurements vital to the Earth system. This past year has been an extremely productive one for NASA Earth science. Last February, the Global Precipitation Measurement Core Observatory was launched with our partners in Japan. And since then, 3 new Earth science spacecraft and sensors have been sent to space to study Earth. 2 of these are now mounted on the International Space Station. Today's launch of SMAP marks the 5th NASA Earth science launch in 11 months. That is phenomenal, if you just think about that. These new missions will help answer some of the critical challenges facing our planet today and in the future: climate change, sea level rise, fresh water resources, and extreme weather events. So SMAP highlights NASA's role as an innovation leader in Earth and climate science. We strive to give the world a consistently expanding view and understanding of our planet from space. Thanks again to the incredible team that have made this launch possible today of our SMAP launch. George?
All right, we'll take questions now. First of all, in social media, if you would like to ask a question, you can use hashtag AskNASA and send in your questions to us. We'll check first to see if we have any questions here in the room from any of our reporters here. Any questions in the room? Okay. All right. Did we get any social media questions? All right. None from social media questions. So in that event, I think that's probably going to conclude our briefing. We are very pleased at the success of SMAC as well as our CubeSats, and we thank all of our participants in our briefings here this week. So with that, that will conclude our briefing and our coverage for the SMAP mission. Thank you. Green board. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines start and liftoff of the Delta II rocket with SMAP, making global observations of soil moisture for climate forecasting.